Hello, and welcome to the CPA Canada Data and Technology presentation on creating a digital twin of your organization using business process analysis and costing. My name is Mike Haley, and I am president and founder of Landmark Decisions.
My name's Jim Ryan, and I am Director of Finance at Crosby Molasses Company Limited.
So our presentation today will give you a bit of introduction on the two companies. We'll more specifically talk about what is a digital twin of an organization, a fairly new term. We'll talk about a methodology that we've been using called business process analysis and costing, and then explore what the role and value of DTO technology is. And then Jim will walk us through their case study of how they've been using BPAC and DTO, and then we'll finish up with a few summary slides around the overall benefits of this approach. So a little bit about the companies. Landmark Decisions is a Canadian niche consulting firm. We've been around almost 30 years now. I'm based here in Halifax, and we also have an office in Toronto. And what we focus on is helping C-level executives and frontline managers improve their decision-making capabilities through operational modeling techniques and costing and profitability analytics. We are subject matter experts with what's called the Consortium for Advanced Management International, or CAMI, which is a member-driven research organization that's been around for about 35 years. We also partner with CPA Canada, many of the provincial CPA organizations, to offer workshops, webinars, and various presentations like this on performance management, operational, and planning and costing.
And from Crosby's perspective, we're a little bit older than Mike's company. We've been in business since 1879. In fact, our senior leadership is fifth generation now, and we are a small, independent, family-owned food business. Also, we are more than molasses, as you would expect from the name. So we are a blending and packer of dry powders. We also play in the co-manufacturing space, as well as provide some liquid bulk storage from our bulk storage plant on the port of St. John. We're about 120 employees, revenues excess of $40 million. That gives you an idea of our size.
Great, thanks, Jim. So let's move into talking about what a DTO is, or digital twin of an organization. Just going to come off camera to make sure we maximize the screen. We have some fairly technical slides coming up, so I'm going to stop my camera there. And you've probably heard the term digital twin, but maybe not digital twin of an organization. Digital twin was coined in about 2002 by Dr. Michael Greaves at the University of Michigan. And digital twin can be best described as a virtual representation of the elements and dynamics of how a thing, a process, or indeed a business operates. So it's really more than a framework. It's more than a schematic. It's more than just a digital automation. It's really an interactive virtual representation of how things work. So the earliest applications of digital twin were with NASA in many of their spacecraft simulation. But it's certainly become more popular over the last 5 years, particularly in manufacturing with the advent of what's called Industry 4.0, which is essentially the digitization of manufacturing. In 2017, Gartner, who's probably the world's largest IT advisory and research firm, coined the term digital twin of an organization. And it was really to segment how digital twin can be applied across the entire enterprise. So their definition is around having a dynamic software model that brings operational and contextual information together to operationalize how the business works, the business model, which would include right from strategy to strategic execution, the current state information, and how, more importantly, it adapts to change by the change in deploying of resources and delivering a customer value. Another definition of DTO from an organization called AI Multiple, which is another IT research and advisory firm. I like this one because it talks about it being a virtual model of the complete business, but more importantly, giving business leaders the ability to analyze, i.e. understand their business, and then tweak the business as needed to achieve their strategic goals. And this comes through the ability to run simulations. So we're going to see how we do this with DTO technology, and Jim's going to talk about how they're using this at Crosby's. Gartner, in their kind of seminal research, which came out last year around technologies that support DTO, think of this as a bit of a journey. So much like you would have a destination and a map to get there, monitoring yourself as you move through that journey to derive value, hopefully, from arriving at that destination, Gartner defines each of these building blocks of DTO in these terms. So digital optimization, the optimized business operations, how the work is done in the enterprise to support business transformation. The business operating model really needs to be customer focused, and a digital model that really support how you deliver your products and services to your stakeholders, of course, which are primarily customers. Business performance management, so the incorporation of performance frameworks. This is where we get at some of the strategic values, some operational financial metrics. And this is based on true real-time or near-time, we like to call it, organizational data that comes from source systems in the enterprise. And ultimately that leads to the information for supporting better decisions. We talk about now what is business process analysis and costing. So this is a methodology that Landmark has been using for about the last 10 years. And we call it BPAC because it really identifies how the business operates and then what the cost impact of that is. And it really focuses on optimizing three key business areas. The business processes. So BPAC incorporates techniques around lean. Many of you may have heard about lean or been involved in lean efficiency improvement projects. It also includes process modeling and the ability to run these simulations or what-if analysis around better processes. It also focuses on optimizing resources. So understanding the connection between the demands of the organization, the products and the services, and the resources required to support those. Understanding where the bottlenecks, the capacities and the utilization of those resources are, and then how those resources are consumed throughout the business process. And last but not least, how can we optimize costs? Now this ties directly to the resources because as we know, resources are where the money is spent in the organization. So traceability of those costs, both fixed and variable, down to the products and services that are offered, allows you to understand better true costs around product, service, and customer profitability analysis. So BPAC is kind of the intersection of these three-legged stool. It allows you to integrate these optimization techniques, create business operating models that have a high degree of visualization to support understanding and collaboration across the organization. So we really say that BPAC provides that foundation for creating the digital twin of the organization. So let's explore each of these components in a little more detail. So under the process optimization, again, lean is a key component of the BPAC methodology. And lean is really about building a culture of continuous improvement that is focused on the customer. So some of you, again, may be very familiar with some of the things like DTO-BPAC as far as a methodology that's define, measure, analyze, improve, and control. Or an older methodology from Edward Deming of PDCA, plan, do, check, act. But really it's all around identifying where are the wastes that occur in the organization. How can we reduce or eliminate those? And that really enables this end-to-end process performance excellence and then improves the way we work and provide value to our clients. Some of you who may have been through Project Management 101 will probably recognize this triangle on the right-hand side, sometimes called the triple constraint or iron triangle. And what it says is basically the cost, the time, and the quality and capacity to deliver your products and services are bounded, like I think the project manager would say, you can give me any two. What lean does is change that perspective. It really helps you rethink that triple constraint, in that you can improve the quality and your capacity to deliver as an organization, reduce the costs, and actually reduce the time to deliver. So that's kind of the promise of BPAC and of DTO. One of the key components of any lean implementation is a methodology called value stream mapping. So we're going to walk through this as a CPG example. This has actually been based off some of the work that was done with Crosby's. So we look at a component of one of their processes, and as Jim described, many of those are pouch filling operations for dry products. Pouches are then filled. They are packed into cases, and those are palletized. Obviously, there's other activities in this process. We're just using this as an illustration. So when we look at total delivery time, or what's called the total lead time, we typically will break these activities of this process into components. And we'll use a little sawtooth to describe that, because there's some time-related data that we need to collect in a value stream. The first of those is what's called the processing time. Think of that as the hands-on time necessary to deliver that particular output of that activity. So in this case, 40, 30, and 10 seconds, based on the number of cases going through each of these process steps. So the total processing time is 80 seconds. The elapsed time is the time from the start of the activity to the completion of that activity, which is typically either the same or longer than the processing time. So this would include kind of time to set up, execute, as opposed to the hands-on time. The hands-on time, the processing time, is really related to how the resource, in this case labor, spends on doing it versus waiting for it. And then we have another component, which is called the wait time. And those are steps between activities. And in the case of this manufacturing operation, wait times could include things like changeovers, when the line has to be brought down to set up for a new product. It could involve breakdowns that stop the line and then interrupt the flow between pouch filling and case packing. Could involve things like product testing, where things are held until product QA comes back with the all clear, as it were, to release the product into the warehouse. So all of these times, so our total wait time here, we can see we can capture all of this, and then this leads to understanding what our total lead time, which is really the sum of the elapsed time plus the wait times, in this case 460 seconds. This gives us an interesting metric called the value added ratio, which is the processing time, the 80 seconds, divided by the total lead time. And that comes out to 17%. Now that may not sound like a really high number. It's actually not bad. Toyota, world-class manufacturer, who actually popularized the use of lean, basically are in the probably 40 to 45%. And so most of the clients we deal with will see anywhere between 5 and 15%. And that really identifies where the opportunities are for improvement. Another component of the lean value stream mapping is a thing called percent complete and accurate. So for each activity, as you flow through the process, you can identify how often is that done completely correct the first time. So we put in some numbers here. In pouch filling, again, in CPG, the actual filling part may be probably the most problematic, shall we say, with misform depending on the equipment, over underweight product that's going in there. So if we say only 94% of the time does the pouch get filled correctly, we have a 6% kind of reject rate. Case packing, a little bit better, but we again may have misformed cases. We may not get all the right pouches into the case and so on. So that's at, let's say, 97%. And palletizing, less likely to be problematic. But when we do what's called the rolled throughput yield, it's really the product of all of these individual percent complete and accurate. So if we do the multiple of this, that comes out to about 90%. So only 90% of the time does a case go through the entire process correctly. So that 10% is opportunity for process improvement, opportunity for lead time reduction. So those are some of the metrics that we want to focus on. When we talk about the other two components of that three-legged stool, the resource and cost optimization, we use a technique called activity-based planning. So I'm sure many of you are familiar with the term activity-based costing. Think of activity-based planning as an evolved form of ABC. And it was derived, and this is where we come back to CAMI, it was derived in some research work done probably about 20 years ago now on the application of activity-based planning for budgeting and operational planning purposes. So we've modified this a little bit. We actually do a higher degree of visualization to improve the understanding. So to do that, we have some symbology that we use. So we have different symbols for fixed and variable resources, which represent our fixed and variable costs. We have rectangles that describe the various activities and various processes. And we have this little home plate, which describes our demand. So if we looked at the example, let's zoom in on that pouch filling operation. Basically, the number of pouches that need to be filled are driven by the demand of a specific product. Let's call that product L1A. So the number of cases that are needed, let's say this time period, let's say it's a month, will dictate how many cases need to be, pouches need to go into that case. And when we look at the resource requirements for producing those pouches, basically we have the line, the production line itself, and we can now start looking at metrics like the production speed. So we know how many, from our probably our ERP system, how many machine hours are required for each case. So that is related to that production speed. We also have our laborers, our line one operators. So we're looking at our labor hours per case. You see I've got this in blue because that's really related to some of the data that we saw in the value stream map, that processing time. So here's where we start to see some of the overlap between ABP and lean value stream mapping. We can also include things like our bill of materials, in this case, a web roll. Those are all the pouches on a roll that has to be then mounted on the machine and ultimately spliced in to create the actual pouches that the material goes in. And because those web rolls have a finite number of pouches, at the end of the roll, they have to be changed. So what does that consume? Well, it actually consumes, first of all, it's described as a non-value added activity because ultimately the customer doesn't want to pay for web roll changes, but we want to identify that as an opportunity cost because what it does, it actually takes time to do that. So the machine actually comes down and two operators have to mount and re-splice in the web roll. And it also consumes the production line itself because the machine is down. So it impacts on the utilization of that production line. So the longer the web roll change, more downtime you have associated with the line and ultimately the cost impact of that. Some other non-value added activities would be considered changeovers. So everything that needs to be done to the line to reconfigure it for product L1B, for example. That too consumes the production line. The line has to be taken down out of production, so opportunity cost lost, and also takes some labor. Now we use some symbology. This is again a very simple diagram, but in the larger diagram we'll show, you'll see some of these purple circles, which actually represent what we call connectors. It allows us to avoid kind of complicated spaghetti networks of interconnectivity. But this really says, okay, I've got operators coming here and the average changeover time, again, another kind of lean metric related to the wait times that are impacted on this changeover. When we talked about percent incomplete and accurate, basically, typically in CPG, there will be some loss in that when a pouch is reworked, there will be some recovery in that. So somebody call this a cost of quality activity, this orange thing. It's also a non-value add activity. And that percent complete and accurate really drives how much rework is done. So that would be, in the case that we just saw, would be 6% of all the cases need to be reworked from a pouch perspective. And that takes time as well. So the average pouch rework time is going to impact on our availability and our utilizations of our resources, as well as the cost impact of doing that post rework. So by looking at the constraints in our business, i.e. how much production time we have, how many operators, how many shifts we have, we can get at that capacity to deliver. And again, if we roll all of these numbers from the bottom up, remember this is a bottom up calculation, we can compare that to the capacity for typically our fixed resources and determine a utilization. How effectively are we using our fixed resources? And again, as you're probably familiar, the higher the utilization, the better the cost impact of that resource. So if we can now calculate this model and we have no broken constraints, i.e. we don't have utilizations over 100%, which would not be practical, we can now look at our costs. So we can layer in our financial information, again, at the resource level. So what is our fully loaded cost per machine hour, our cost of our labor, our cost of our bill of materials, in this case, the web roll. And we can pull those dollars back down through the model because we've already established those operational flows. And that allows us to get at the cost to deliver. And it's really interesting in that because we are using fully loaded costs, because we're capturing the intricacies of the process, we can get very detailed cost information. In this case, pouch rework. So it's not just the cost of the wasted pouch, and it's not just the cost of the time the operator has to deal with that misformed pouch, but it also includes a portion of all of the costs of the actual pouch filling, including a slice of the web roll changes that needed to be taken place before the pouch was misformed. So we get a very detailed cost information. We'll show you that in how some of the technology works that supports this. So really that gives us the overall ability from a cost to deliver point of view. Okay, so in summary, we say lean, as you may be aware, lean and ABP are powerful techniques in their own right. Lean really focus on the elimination or decrease of waste, the focus on the customer, and building this culture of continuous improvement in the organization. ABP, bringing together operational financial flows and metrics to identify where resources and resource constraints are that can limit the growth of the organization, both strategically and operationally, and the ability to do a modeling approach that allows what if and scenario simulations. But when those two methodologies are brought together, that's what we call the BPAC DTO modeling. And that really allows you to enhance value stream maps to include now resources and costs associated with the value stream that helps you identify and perhaps prioritize which lean initiatives are going to have the best impact on the bottom line. And overall gives you the ability to better manage organizational capacity and your ability to change to execute on the overall strategy. So I want to shift now to talk a little bit about technologies that support DTO modeling. So again, back to Gartner. So you'll remember the 5 components of Gartner's DTO journey. They also do a classification of the various technologies that support each of these particular steps. So typically a DTO technology will be a combination of different classes of tools to achieve different things. And these things will be kind of interrelated and stitched together. And if we look at where BPAC's at, the sweet spot for the BPAC methodology is really around the mapping and the performance using some of these tools. Because business operating model capabilities look around modeling and analysis of business operations and understanding where the resources. So that last diagram that I walked you through shows how resources are deployed to deliver on the outputs of the organization. Allows you to model those products, services, other information, and kind of capture the flows of those resources and ultimately the cost of those resources. The business performance management capability brings operational and financial metrics together into performance scorecards or performance dashboards and allows you to do scenario tests, what they call scenario testing, we call it scenario playing, and predictive analytics around the cost and the value of changes that are made in the organization. So here are some examples in each of these classes. So enterprise business process analysis tools, There's a lot more. In fact, this reference, and you'll see it in the handout. You'll be able to click to this link to go to that Gartner report, where it'll list a variety of other technologies. Enterprise architecture tools. So these are quite often the foundation for bringing information together around how the business operates and the different information sources and the interrelationships between those sources. ERP systems, I'm sure many of you are familiar with Oracle and SAP. There's also specialized ERP. SysPro, for example, is one that's used by Crosby's. It's a kind of a niche ERP system for manufacturing and distribution. And again, I'm sure many of you are familiar with business analysis or business intelligence tools, IBM Cognos, Microsoft Power BI, and Tableau being examples of those. So in Crosby's case, what we're going to explore is their use of this set of DTO technologies. Collaborative Business Planning is a Canadian product. It's an Ottawa-based firm that has actually built an application on an enterprise architecture tool called Qualiware. Qualiware is the Government of Canada's standard for enterprise architecture and widely used throughout the federal departments as well as other provincial and private sector organizations. SysPro I mentioned as Crosby's ERP system. And Crosby's has the luxury of having two BI tools. We'll focus on some of the work done with Power BI, but Tableau is another common tool, and Crosby's uses Tableau as well. So let's move now to talking about an illustration of a DTO technologies, the ones that Crosby's are using. So the model I'm going to take you through, or the models I'm going to take you through, are based on the Crosby's work, so very similar. Obviously, this is fictitious data that we've created as a demo to illustrate the concepts and how the DTO technology called Collaborative Business Planning and Power BI dashboards can work together. So I'm just going to jump to that. So again, we won't have time, obviously, to get into too many of the intricacies, but I'll explain some of the fundamental components of this tool set. So basically, it's a very visual diagrammatic tool. We talked about the symbology that's used. So for example, the home plates on kind of pointing down are fixed resources. The ones that have a kind of a rounded top, so electricity, for example, or overtime are variable resources. And then anything that's a rectangle are different activities. So if we look at just this page at the top here, typically we'll have our resources at the top of our visual model. We'll have the activities and processes in between and those supporting demands below. So I'm just going to go through this high level example. So we have a facility that houses, we look at all the connections here, the management team. So this is a fully costed operational model, which includes SG&A costs. So the management team oversees a variety of labor groups, maintenance, QA, warehouse, the production area, so lead hands or supervisors, which oversee operators and packers. Those are the two, I'll say, frontline staff that are down in the production area. You'll also see we have some various activities here. So under maintenance, for example, we have two of the key things they do. They do preventative maintenance and they do repairs. Now, there's a little key over here on the right-hand side because this model allows us actually to look at what's called the total cost of quality as well. And total cost of quality is broken into the cost of good quality and the cost of poor quality. So things like prevention and appraisal costs are considered good, although they do cost. And the ones that really cost organization are failure costs, either internal or external failure costs. So we can use some coloring that can be set for any of these objects. So we're using orange here to represent internal failure costs. So obviously the maintenance team going out and repairing equipment would be considered internal failure. We have some appraisal costs. So developing and maintaining customer QA specs is a good thing. It allows the organization to manufacture to that particular specification. Things like preventative costs, so the preventative maintenance, or maybe even training of operators to better execute on the line and how the line operates. would be considered a cost of good quality. So we can flag these types of activities as we move. The other thing you'll see, a lot of these little green symbols that have a V for it, and they represent variables. So in the case of our labor, our frontline labor, it tells us how many operators, how many FTEs we have. It tells us how many packers we have. We can use variables to represent the average wage, the hourly rate, in this case of the operators versus the packers. And we can also use them to define things like shift parameters. So, you know, what is the maximum number of days per month of business days that are run? This is a monthly model. You'll see that up here in this summary. So we know how many maximum shifts that become. That'll have an impact on the total product that could be run. The other ones are what is the practical capacity of our labor? So we have 12-hour shifts, but we only get about 10.5 hours worth of work out of these individuals because we have to give them lunch, we have to give them breaks and so on. And then we can look at how many shifts each FTE works and overall what the practical capacity is, which is based on these practical hours. So all of these numbers can be brought onto the diagrams, which allows and facilitates easy scenario and simulation. I'll show that a little later. If I move down through the model, I can look at production lines. So in this illustration, we have two production lines, line 1, line 2. Line 1 has some dedicated operators and dedicated packers to produce that line. And then the line itself, which obviously occupies space, we see this connector now to plant. So there's some square foot allocation for this particular production area. And that line is used in 3 ways. It's used when it's running, i.e. producing product, and this is where the electricity will be consumed. So that'll go down, you'll see that on the next page where we have the line 1 runtime. But it's also consumed when we stop the line at the end of the shift to do some cleaning. Okay, this is food production, so hygiene is very, very important. It needs to be done on a shift by shift basis. And obviously preventative maintenance. The line again has to be taken down, preventative maintenance done. That helps improve the overall capacity or runtime capabilities. So we see those connections. We also see this over on line 2. It's a bit of a mirror image here, although we have some unique parameters around line 2 because it includes a cartoner. So in line 1, pouches go directly to cases. In line 2, they go into cartons, and the cartons go into cases. So there is some discrimination between the 2 lines. Again, we won't have time to go into all the details around that. Just want to give you a feel for the flexibility of how DTO models are created. If I go down to a typical production line, this is for that product L1A we talked about. So here's our pouch filling operation. But in advance of that, we have to move raw materials into the production area. We create production paperwork. We then fill the pouches, which includes our web roll changes. Those pouches then get case packed and then palletized and then moved to the warehouse. We also, though, include other activities. So our breakdown. So we want to capture the mechanics around how often that line breaks down when creating this product. Again, this will be operational data that's typically collected in manufacturing, and we can use that in this model. Our pouch rework. So the pouch rework, 4%, that represents actually a 96% complete and accurate. So again, we use these variables to allow us to flex parameters, operational parameters, and financial parameters within the model. The variable resources you'll see here, these 3 objects, are part of the bill of materials. So we pay for our web rolls, we pay for our ingredients, we pay for our case costs. So those can be summed up for our BOMs. We look at things like changeovers because that consumes time, it consumes the line as well. So all of these, we have a flow here, but there's also other supporting activities that take place in that process. In the upper right here, we have some production data information. We look at things like production speeds, how large typical runs are, parameters around how many pouches per case, and these will vary from product to product. And again, gives us the ability to do these simulations and change these. I'll show that shortly. And last but not least, if we go down, I've structured this model to look at from a customer product and profitability perspective. So each of our customers consume the 3 different products this demo has at different rates. They have different volumes. They have different pricing for each customer. They have things like different returns that come from each type of customer. So we can actually drive the number of customer orders will drive the production of each of these 3 products with their particular parameters. So if I go ahead and calculate this model, this is an uncalculated model, so we don't see any information. So again, remember that the activity-based planning component of this actually moves from bottom to top. So I'm going to actually run my calculation. I'm going to click on the calculate button. And what it'll do is it'll move all this data, the number of cases, up through the model. We don't get any financial information. We have to make sure we can operationally achieve the results. So let's go up and look at that. So now we can actually start to see how many cases we are going to need this particular month. We see on average how many breakdowns we would expect this month based on the historical maintenance records and breakdown records. We see how many extra pouches we'll have to create based on the pouch rework averages, how many changeovers we have, how many rolls and roll changes that we'll need. And if I continue up the model, I can now look at how well am I utilizing my resources. So we see that in line 1, the operators are working pretty hard at 96%. There's a little bit of flex though in the packers. So there's probably some opportunity here on the packers. And if I go to the top of the model now, I can actually see some of those flows that show me how many maintenance hours, how many PM hours, and so on, driven again from the bottom and the production requirements. I can then do my second pass calculation because I've got no broken constraints. I calculate that model again and calculate the financials. So when we talk about financials, let's look at, let's start here. We basically say, hey, what our total revenue is, what our total cost is, and our total profit. So this company is producing this month a positive profit line. Not huge, but it is positive. And we look at some of these costs. We drill into each of these activities. If I open up the plant and I look at, here's where I would tie into my GL. So I know all of the plant related costs here and how much I would pay on a monthly basis. From here, I can actually look at how that flows. So if I go to my links, I can actually see where the plant flows to, and some operational information as to how many square feet are allocated to each of these components, and then what is that percent of that flow, which drives the actual costs that flow down to each of these areas. So this is how I'm basically allocating and distributing my plant-related costs. If I go down, and let's go down a little further in the model, if I go down to the operators, and I'll open that up, and if we look at what kind of costs, what kind of direct costs we have, here's where we would be paying our operators. And this is calculated by a formula which brings in some of these variables, i.e. the number of FTEs, the hourly rate, how many shifts are run, to calculate our total financials. So as we flex any of these variables, we'll see a cost impact here. Those variables are also used in determining dynamically calculating the capacity. And when we look at our summary results, we can actually see that we have direct costs about $52,000, but we have inflow costs from the supervisors, from the management team, from the plant, basically our total cost. So when we talk about a fully loaded cost, we're talking about the use of operators at around $37 per hour. And again, we can do, like before, the links that flow, so I can see what's directly above and what's directly below and where that goes. I can also see what's called the PMO. These are called primary modeling objects. And if I look at my primary modeling object contribution, I can see, again, a blend of some operational information and financial information. So basically 17 kilowatt hours that are required for the plant and its distribution down to the operator for my total cost, my component, and I can see the distribution of those costs. So as I move down through the model, I can see things like, what is my total cost for my line, which includes my plant allocated costs. what the cost of shift cleaning is, in this case, $7,500 per month. That's the cost. And if I could marry that up with my shift cleaning on line 2, you know, I'm spending about $20,000 a month just on the sanitation component required for this production facility. I can see the cost of preventive maintenance. And if I go down now to the production area, I see some interesting cost information, typically not available elsewhere, i.e. what is the cost of a breakdown? $250 for every time we break down, $189 for every changeover. So we see these are identified as non-value added, the ones that are red. So these are opportunity costs for us. And we can start to understand the impact of this by looking at some scenario planning. Before we do that, let's go down to the actual customer segmentation that we have, just the 3 customers granted. So that $37,000 of total profit, we see that a lot of that is coming from customer 1. So customer 1 on average is very profitable. Customer 2 is slightly profitable. Unfortunately, we're giving all that profit back to customer 3. They're very unprofitable. So when we do customer profitability analysis, we can say, what can we do with that customer to improve the bottom line for the organization, including the term firing the customer. So now you've got evidence around why you'd want to do that. Hopefully improve things, but then maybe look at the customer rationalization. So if we were going to run scenarios here, we can actually do that. Let's say we had talked to the sales and marketing team, and they say product L1A, which is consumed by all 3 customers. Basically, if we could improve or drop the price, let's say by $2 per case for each of these customers, we would expect to see a volume increase of 25%. So what would the impact be operationally and financially of that change? So we can simulate that by going in and let's say we're going to increase this to $12,500. That's the 25% increase by reducing this cost by $2, so 22 to 20. I'll do the same for customer 2. We'll take that from $6,000 to $7,500, and I'll reduce that cost by $2, so I'll take that down to 22. And I'll finally do customer 3. They don't take as much of that product, but we'll also reduce their cost down to 24. Now I can recalculate the model. One thing you'll notice with these DTO models is that when there's a change to the data, all of the financial and operational results disappear. So we need to recalculate that model. And if I do that, I find out that, oh, I've got a warning coming up. So I have some constraint in the business that has now been broken, i.e. over 100% utilization. So I can go and I can find out where that is. I can use the message window. I won't go to there. I'll just zip up here and we'll see that the issue is on line 1. Remember, it was line 1 product that we increased. So we don't have enough operators to be able to deliver on that volume increase. So now we have some business decisions to make. What could be done? We could increase the number of shifts. We could actually see what the impact. So if we just added, let's say 10% more shifts. So I take the number of shifts next month, let's say from 40 to 44, I recalculate the model. I don't get any broken constraint warning. I'm at 97%, which is similar to what I was before. And if I go up and I now say, well, what's the financial impact? Operationally, we can achieve this now by adding those 4 shifts. Let's recalculate the financials. And we've actually lost money in doing that. Our profitability has dropped from about $37,500 to $35,000. So we've lost about $2,500 in doing that. So we'd have to make a decision, was that worth that particular change? A more proactive approach, one that involves some lean, might be to sort of say, what could we do to improve the business process? So I'm going to back and I'm going to reset that to the broken constraint situation. If I just run that again, we'll see that we get that broken constraint back. And now let's look at the opportunities that exist in that line. So one of the ways to do that is to use the value stream mapping. So typically we'll build the value stream map. And if I look at that for line 1A, it looks similar activities, just a little bit different flow. So we actually see what's called the on-cycle flow. So this is the product moving through the line. So there's what we looked at in our diagram, the pouch fill, case packing, and palletizing. but we have some lean parameters around each of those, the lead time, the processing time, the percent complete and accurate. And we can actually calculate this as well. And what this does is creates what's called the VSM timeline along the bottom, that sawtooth that you saw in the diagram. And I can get at some details around the overall value-added ratio, the rolled throughput yield numbers associated with that. We can also get information around how much staff is required for each of these activities. So now we can look at how can we optimize each of the activities or the flow through each of these activities. You'll see these non-value added activities, the changeovers, the roll changes, pouch rework, breakdowns, they actually can have an impact on some of these wait times, which then has an impact on the value added ratio. So if I go back to the AVP component of this model, I can start looking at opportunities. So if I could, let's say maybe do some better operator training. You'll remember we had that operator training on the resource page. So let's put that in place. Let's do some more education. And what would the impact be? We could potentially speed up that line. So instead of 100 cases per hour, let's make that a 10% increase. So I'm going to go to 110. That would give me the ability to run longer runs, more cases per shift. So I'll take that up by about 10%. Understanding the business process, we can maybe speed up our changeovers a little bit better. So let's say instead of 30 minutes, we could do 15 minutes. So maybe there's some training around better assembly of equipment and materials before the changeover that speeds that up. Maybe we can have an impact on our breakdown rate. So instead of one breakdown every 1,000 cases, maybe we can get that down to half, because now the operators understand what to look for, where some of the equipment may be breaking down, and anticipate that and resolve that before the breakdown. And maybe even the breakdown time, maybe working with maintenance and doing some training with them, we could get that down to 15 minutes instead of 30 minutes. So some changes made on that line 1A production. If I run that model now, I see, oh, that's great. I don't have a broken constraint. I'm able to make that new volume. Remember, this was 18,000. We've gone up to about 23,000 cases now. If I go back up, I look at my utilization. I'm running my line 1 operators a little hard here. So I might want to consider potentially adding another shift to bring this back. We don't want to overstep our balance with our utilization from before. However, the opportunity here, when I recalculate my financials, this drives a higher profit line. So about a $25,000 per month increase in profitability. So having that extra volume, even though we drop the price, and that can simulate a process improvement, can drive a more healthy bottom line using that profit. So this is kind of the modeling technology for building these DTO models. This one, again, collaborative business planning is the tool that we're showing here, and the one that Crosby has been using. We can bring all of this information into a normalized results data set, and then you can apply some BI technology to that. So this is an example of Power BI, Microsoft Power BI. And we can structure this. I'm sure many are familiar with dashboarding technologies. So here we're looking at a customer profitability analysis. I've got a variety of scenarios. In the more expanded demo, we have a number of scenarios that could be run. We can look at, for each of these scenarios and each type of customer, what those costs would be. We can see the breakdown. So this is kind of the financial, 267,000 for customer orders, customer 1. But we see the components and how much operationally of each resource is required. We don't lose the conventional kind of P&L kind of statement for this particular customer. And as we change from customer to customer, we can see those being updated. And if we change to our training scenario, the high level one that I do, I can see we can actually make a negative or a losing proposition with customer 3, turn that into a slightly positive if we make some changes around that. We can look at things just purely operational. I can look at my utilizations. I can understand how well I'm using my resources. In this case, I've got opportunities here around how to better use my packers because their utilizations are low. Same thing with my line 2 cartoner, for example. Low utilizations means opportunity cost. I can look at key activities. So I can group some of these value and non-value add activities and look at their overall cost impact across the model. So these kind of reddish ones represent some of our non-value add activities, and again, opportunities for improvement. So if I want to look at this one on rework, I select the rework. I see all of the resources and the component resources supporting that particular cost of $85,000 a month on rework. Obviously an opportunity for improvement there. And last but not least, I talked about total cost of quality. If that was an area that was of interest, I can sum up all of the costs of good quality, the sum of poor quality, for my total cost of quality. I can see the distribution, I can see the resources, and then I can look at that on a scenario by scenario basis to sort of say, okay, obviously by doing more training, I've reduced my overall cost of quality. I've increased my cost of good quality, but that has helped me decrease the cost of poor quality, which are the failure costs associated with it. So scenarios can be provided and dashboards provided to the management team to support this kind of knowledge and better information. Okay, so I'm going to turn the stage over to Jim to walk us through the Crosby's example and how they work with the BPAC and the DTO technology. Jim.
Thanks, Mike. Yeah, so I wanted to give you a little flavor of kind of our CBP journey or experience to date, and we are still in the learning stages, but so far so good for our from our end. A little bit of the history around the time I learned about Mike's tool here was through a PED course, much like yourselves today. We were experiencing a little, I would say, problem with our trust and our costing within the organizations from various parts of the organization, and that was kind of our background. And when I came across Mike's offering for the activity-based activity planning costing course, decided to take that and was pleasantly surprised, and we moved forward from there. In terms of implementation approach, as you might have guessed, it was a multifunctional team. We used people on our team as champions from the ops side of it, from our continuous improvement department, and from our finance department. And one of the silver linings, and I'll mention a couple that came from this, was this cross-functional team. It was basically 3 individuals worked very close together and that team fostered a lot of learning within their individual departments as well, and trust in the project, I would say, throughout the organization, simply because it was definitely not just a plain finance-driven course or project, excuse me, or an operational one. We sent these individuals on some training through Mike's organization, so more in-depth training on the concepts, the approaches, and the tools that are used through in this project and with this course of study. We used phased-in modeling approach, and later we'll see a slide of that. We wanted to break it down to a bite-size type approach for us, so kind of really learning to walk before we ran in learnings that happened in, say, phase 1 of our project, what worked well, what didn't work well, and what was really useful was we were able to roll into the next phase and the final phase for the target piece of organization that we've applied the tool to. Very important to get our plant management and production staff involved, and you'll see in a upcoming slide a tool, the project analysis tool, process analysis tool, excuse me, that was used. And a silver lining that came from this particular tool was that we really drove down to the individuals involved in the process as they are as we all know, the subject matter experts of their piece of the job. And that really fostered great participation and collaboration throughout the project and throughout the organization from the production floor. So that was a silver lining that I'd like to highlight. The model design and coaching support, we opted for a fairly iterative approach, and Mike's approach is fairly iterative with us throughout the project. Definitely in the first stages, it was somewhat constrained in terms of personal touch, simply because we were in the midst of COVID. And all that shutdowns that were entailed through that. But we accomplished it, obviously through the Zoom tool, but also we did some videotaping of our processes and things like that we were able to communicate back and forth with Mike on. And Mike did actually make a visit, and the close touch, the back and forth was very helpful for us in the early stages that our team found. And obviously our senior leadership team, we had a great buy-in from our VP Ops, and she became a real champion for this project as well. So that coupled with the other departments' upward support of really spelled good news for this project, and people were happy with the results. If we flip to the next slide here, this is kind of an example of our phased-in process. So this is a simplified schematic of our processes on our finished packing side of our business. You'll see the wet products and the dry products. Our bite-size pilot project was really around the drink crystal. So this is where we had fairly close contact with Mike's team and our team, and this is where most of our learnings initially took place. As I said, what worked well, what didn't work well, and how we could apply that onto the next part of our phase one, which was basically the rest of our dry side, jellies and sugars and hot chocolate. And so that was accomplished, and again with the assistance of Mike. And then the wet side of our business was our final phase, and that was really done by our team. So the learnings had transferred from the pilot through phase one of the organization that was required to carry out the project, as well as the particular capabilities of the tool, and our team was able to carry out the wet side of our business and implement that into the model by themselves, which was encouraging, because we want the knowledge obviously to stay with our team on the project. This slide here is part of that project analysis sheet that I had mentioned before, and it really gave a systematic approach to the process of kind of enumerating the steps involved. Very, very important to that this analysis captures all the key activities, not just the production activities. So yes, the end of week cleaning, the pouch rework, the web roll change, all that stuff, because that will be needed, as Mike had mentioned earlier, for capacity planning. And it does highlight, once it's costed, as Mike had showed kind of in his demo, some of the areas get highlighted as to total resources used, but also provides the opportunities where changes can be made. And we found that in a number of cases, some of our processes we have revamped since the project to increase capacity, but also increase efficiency and drive resource costs down. We found that this part of the project, these tools, this process analysis tools, was key to driving some of those new learnings. So in terms of the key benefits coming, as I kind of mentioned off the top, traditional product cost comparison, improving costing precision. So that's kind of where we jumped off with this project to start with, to bring Mike involved, to get Mike involved with our team as well. Product line optimizations, as I mentioned, some of that process analysis and the costing throughout the model has driven us to change some of our process for the better. And investment in ROI determinations. We've used that in terms of reducing our non-value added activity. And by that, I mean, seeing how much of our resources were tied up in those activities, we were able to make business cases for perhaps an outside new tool for us to help us cut back on that those extra costs that aren't adding any value to the customer. So we've changed our sanitation processes and improved productivity there. And we've also changed some of our information gathering done throughout the line for efficiency and safety and quality needs to a new and improved management tool, which the cost of which we were able to make a business case for by learning where the resources were being tied up. And the annual budget and planning, including our additions of new projects, was a simple war story on that. We were flexing the model there. We had an opportunity on a new piece of business coming in. We were able to use the model to plug that in, and as Mike showed in his demo, one of the resources went tilt. And so we were able to catch that early on, able to make an adjustment and use that in our evaluation of that business opportunity. So that was very intuitive and very quick in the early stages of that planning process. So very helpful in that regard. Next steps for us, we, as I mentioned in my introduction, we have what we call the west side part of our operation. So this is our bulk operations from our onshoring of our raw product, but also third-party storage and handling of bulk food products on that. So we definitely see rolling this out to that part of the business as well. And just the proliferation of dashboards throughout the organization for a wider management usage is definitely on the project table for us to continue with. So yeah, so that's kind of where we were at before this project came in, and very happy with the benefits that we were able to come out of this project and the new learnings that are now ingrained in our people in our building. Thanks, Mike.
Yeah, thanks, Jim. So I just want to finish up with a couple of summary slides, hopefully to bring this all together for you. Basically, DTO models allow organizations to convert what's often considered disparate data, financial and operational data, never the twain shall meet, into actionable insights. So by understanding your business operating model, that actually provides the insights to collect the appropriate data from your organizational systems, be they your ERP systems, your labor, HR payroll systems, your financial systems, obviously. Bring that data in to support the way business is done. And then that provides the ability to better visualize and understand the business processes, as Jim pointed out, as to what happened in Crosby's. The ability to run scenarios, that budgetary description he provided to understand the impact of new products, and then to create dashboards that allow everyone in the organization to see this new information, consume this new information, to ultimately, drive a common understanding and common benefits. We also like to say that DTO models provide the ability for multifunctional and collaborative insights. So from a strategic point of view, looking at new products, how customers might be rationalized and optimized, capital investments, the return on investments around business decisions for new equipment, new products, new services. On the operational side, better resource planning, tie into quality management. I showed that in the demo and the total cost of quality. The ability to use DTO models to help facilitate lean process improvements, provide more rigor and discipline to lean initiatives. And then, of course, financially, better costing and better budgeting. Through that, the ability to reflect on pricing and service fees associated with the services that are offered, which then impact on the profitability. So in Crosby's example that Jim walked us through, there were multiple benefits across those functional areas, and I'm sure as they continue on with their DTO journey, they'll begin to realize other benefits in addition to what they've done so far. So we'd like to thank you for taking the time to watch this presentation. We hope you come away with a better understanding of digital twin, and more appropriately, digital twin of an organization, and how methodologies like BPAC and various technologies can support that. By all means, if you have any questions or comments on this presentation, please feel free to reach out to myself or to Jim, and we'd be happy to answer those. So thank you again.